All right, we're going to be looking at 3 formulas today involving circles. So we're going to be looking a little more closely at how to calculate specific parts of a circle. So the first thing we're going to look at is what we call sector area. So let's define what sector area is first. So go ahead and put a center of a circle. Let's call this circle circle B. And what we're going to do is we're going to basically cut a piece out of this circle, so kind of like a pie piece. So we're going to create this radius B to A, and this radius B to C. And then what I just created was I just created a sector. So the sector is basically this red shaded region. So this is what we call our sector area. So it's going to be basically the area of one piece of this giant circle. So like one piece of the pie, if you will. Okay? Now, the important pieces for this circle, for us to calculate it, are 2 things. So we want to know the length of the radius and also the measure of the arc. And remember, that arc measurement could also be the central angle, so they're the same thing. All right? And sector area is one simple formula, pi r squared, which is the area of a circle, right, times m over 360. And that's going to tell us what portion of that 360 degree circle are we actually calculating. So again, it's the area of the circle, pi r squared, and then times just the piece we want, so m over 360. Okay? So take a look at example 1. We want to find the area of sector HGJ. So when we're talking about sector HGJ, we want to go ahead and look at the sector defined by that central angle. So this shaded region is a sector we're looking for. Okay? So remember, go ahead and write your formula. So area of sector HGJ is going to be pi times radius squared times m over 360. Right? So here our radius is given to us. Our central angle measure, which is also the arc measure, is 30. Super simple, plug it all in, and let's see what we get. So this is going to be pi times 5 squared times 30 over 360. Now I want you to leave your answer in terms of pi, so you want to make sure you don't round your fraction. So you want to be careful with that. So we're going to get 25 pi times 30 over 360, which I could actually reduce down to 1/12. So then my final answer is going to be 25 over 12 pi. Again, this is area, so it's going to be square units. All right. So again, leave your answer in terms of pi as an exact answer. Reduce that fraction. Okay? And that is sector area. Now, arc length is exactly what it sounds like. We want to find the length of y to z. So what is the distance from y to z? This part of the circumference is what we call arc length. So again, it's part of the circumference. So what do you think is going to be part of our formula for arc length? The circumference. And again, it's just one piece of the circumference, so it's going to look very similar to sector area, so just be very careful, okay? So arc length, oops, I can spell L-E-N-G-T-H. That's going to equal, again, circumference, which is 2 pi r, times the piece of the circle. So that's still going to be m over 360. So once again, we do need the degree, and we still do need the length of the radius. Okay? So let's go ahead and do one last problem, and we are done. So we want to find the length of arc BC. So you want to make sure you see the difference between length and measure. Measure means the angle. Length means the actual distance. Okay? So arc length, again, the formula, that length is going to be 2 pi r times m over 360. Now take a look at what we have, right? radius is 4, m is 112. And again, you can either be given the arc measure or the central angle. They'll give you the same thing. Just plug it in, right? 2 pi times 4 times 112 over 360. We're going to round this in the nearest hundredth this time, so go ahead and just work this whole thing out. And there you go. So I did it both in terms of pi, so you guys can see what it would look like in terms of pi, but also rounded to the nearest hundredth. And because we're talking about length, it's not square inches, it's just plain old inches. Okay? 3 formulas, or 3 ways to really solve today. And we'll be practicing this in class. Make sure you do go back and review how to find the area of that triangle, though. All right? Come back with questions. Thanks for listening.